Today we're going to talk about infinite limits. We're going to take a look at something we did earlier in the chapter, but just look at it in a slightly different way. So let me remind you guys of something back when we were doing limits analytically. We said if you're trying to do a limit and you tried your x substitution, you plug in your number for x and you get any constant over 0. Anything other than 0 over 0. So you get like 5 over 0 or negative 20 over 0, something like that. We said on the graph, that represents a vertical asymptote. Now remember at the time I said, for now, we're just going to say it does not exist. The limit does not exist. But I told you we're going to change it, and now is when we're going to do that. So basically what I was waiting for is I wanted to show you one-sided limits, which we did in the last lesson first. Now that we've seen one-sided limits, we're going to be able to be a little bit more specific with this answer. Rather than just saying does not exist for every single one, we're going to be able to talk about either side separately. So first of all, if you're talking about one-sided limits at a vertical asymptote, let's take a look at what that looks like. So let's say I have a graph and it has a vertical asymptote right here. And I'm going to make something up. I'm going to say, let's say on one side it's turning up, and on the other side it's turning down. So this is the visual of what would have happened if there was some function, we were trying to do a limit, and we plugged in some numbers and got a constant over 0, like 10 over 0. So what we would have said before is does not exist. But now all of a sudden we can look at one side at a time. And basically, depending on whether the graph is turning up or turning down on that side, the answer is going to be positive or negative infinity. So for this picture that I just drew, if I was doing the limit as x approaches, I'm just going to call it a for whatever number that vertical asymptote is. If I was doing it from the left, the limit as x approaches a from the left of f of x, then basically what I'm looking at is this part of the graph right here, just to the left of that line. Now because it's turning up there, the answer would be positive infinity. Now, if I wanted to do the limit on the right, the limit as x approaches a from the right with the little plus of f of x, then I'm looking at the graph on the other side of the line. I'm saying if I go just to the right side of that line, then I see this. Now, because it's turning down, because that arrow is pointing down, that answer would be negative infinity. Now the answer to this particular question itself, if I just ask you what is the limit as x approaches a of f of x, period, with no plus or minus, then the answer would be does not exist. And remember what we said about limits is, and it's the same rules as before, if the limit from the left and the limit from the right are the same, that's the answer. If they're different, like this one of them is positive infinity and one of them is negative, then the limit answer would be does not exist. So let's talk about those possible final answers for not one-sided limits, but for a regular two-sided limit. So our normal limits, without the plus or minus, are two-sided limits. The answer could be positive infinity, negative infinity, or does not exist. And I'll show you one example of each. We actually just saw an example of does not exist. But basically, if you have an asymptote, and I'll draw a real similar picture of the one I just drew. If you have a vertical asymptote, but let's say it's turning up on both sides. Let's say it turns up here, and on the other side it also turns up. See, that's an example where the limit, we wouldn't say does not exist anymore. The limit as x approaches a of f of x would equal positive infinity, because they're both turning up. It's positive infinity on the left, it's positive infinity on the right. They're both the same, so that's the answer to the limit question. Then, if I did the same thing, but I drew one where let's say they're both turning down near the asymptote, like this. That would be an example where the limit as x approaches a of f of x equals negative infinity. Because it's negative infinity on the left, negative infinity on the right, it's the same on both sides, and that means that number is the answer. Now the third picture, I won't even bother redrawing it, just jump back in the video if you want to see it again. It's the very last slide. Basically, if you have one of each, if it's turning up on one side and down on the other, that limit does not exist. All right, so let's say we figure out, we're doing direct substitution, we plug in a number, we get a constant over 0, we get 7 over 0. So you know it's a vertical asymptote, and we need to decide what the answer is. Is it a positive infinity? Is it a negative infinity? Or is it one of each, and we say does not exist? Now there's two ways to do that. The best way to do it is graph it. And I said graph it on your graphing calculator or Desmos or some sort of graphing utility. If you happen to be able to do that, if you're allowed to use Desmos, definitely just graph it. And just take a look. Again, if they're both turning up, we say the answer is positive infinity. If they're both turning down, we say it's negative infinity. And if it's one of each, one up and one down, we say does not exist. Now, let's say you're in a situation where you're not allowed to use a graphing calculator or Desmos or anything like that. The other possibility, and remember, this is only if you don't have Desmos, what you do is basically make a quick XY table. You plug in two numbers, one very, very close to A, but a tiny bit less, one very, very close to A, but a tiny bit more, and see if you're getting a positive number or a negative number. If you're getting positives for both of them, it's positive infinity. If you're getting negatives for both of them, it's negative infinity. And if you get one of each, it does not exist. So let's try out an example. We have the limit as x approaches -1 of x over x plus 1. So don't think about infinity yet. Don't think about vertical asymptote yet. If you think back a couple sections, what I said is, if I ask you to evaluate a limit from the equation like this, always try direct substitution first. So I'm going to plug in -1 for x. That would give me -1 on top, and on bottom it would give me -1 plus 1, which is 0. So I get -1 over 0, constant over 0, and that means it definitely is a vertical asymptote. But unlike before, I don't just automatically write DNE and move on. I want to know what it looks like, because we could have an answer of one of those three things: positive infinity, negative infinity, or one of each. So I'm actually going to show you both methods. I told you there's two ways of doing it, but I'm going to start with Desmos because that's the better way when you're able to do it. So let's do that now. Okay, so here we are in Desmos. You can see I've typed in the equation for us. It's x over x plus 1. And since we're doing the limit as x approaches -1, I'm going to put that vertical line in. I'm going to type x equal -1 also. And that really shows us the vertical asymptote, because we already decided from our work, we know there's a vertical asymptote. So the blue line there represents the asymptote. And what I'm looking for is what's happening on either side. Now this is one of those pictures like I showed you earlier in the notes. If I look on the left-hand side, it's turning up. It's going to positive infinity. But if I look on the right-hand side, it's turning down. It's going to negative infinity. So basically, the answer to the question is going to be does not exist. So this is what we just saw in Desmos. If we take a look at the one-sided limits on this problem separately, we get different answers. So for example, if I did the limit as x approaches -1 from the left of x over x plus 1, that was the graph on the left. That was turning up, so I would say that answer is positive infinity. Now if I did the limit as x approaches -1 from the right of x over x plus 1, that's where it was turning down on the right side of the line, so that would be negative infinity. So what we decided from those two pieces of information, because it's different, it's positive infinity on one side, negative infinity on the other, the answer was does not exist. Now, before I move on, I said I want to show you what I would do if I didn't have Desmos. So remember, there may be a situation where you need to answer a limit question like this, and you need to know whether it's going to positive or negative infinity on both sides, and you're not allowed to use your graphing calculator or Desmos. So what I said is, you can kind of make an XY table, and you can plug in numbers just a tiny bit bigger or smaller than -1. So like I might do -1.1 which is a tiny bit smaller, that's on the left-hand side, or negative 0.9, that's a tiny bit bigger, and just see what you get. So for example, if I did negative 1.1, I would have negative 1.1 over negative 1.1 plus 1, which would be negative 1.1 over, and that would be negative 0.1. Now, I'm not even really that concerned with the answer, because again, we're going to say we don't have a calculator. Let's say this is a no calculator question. But what I see is that negative over negative is going to turn into a positive number. So I'm going to get some sort of positive number here. So my guess is that we are going to positive infinity. And that's exactly what we saw on our graph. For numbers that are a little bit smaller than negative 1, or to the left of negative 1, we're getting positive numbers. Now if I do something just to the right of negative 1, or negative 0.9, and I substitute that into my original function, I would have negative 0.9 over negative 0.9 plus 1, which would be negative 0.9 over positive 0.1. See, now we're dividing negative by positive, and we are getting a negative number. And that's exactly what our graph showed us. So this work over here, I'll kind of split it with a line. The work on the left hand was just basically my answers from looking at the graph. The work on the right side of the line is if I was not allowed to use the graph and I had to figure it out by hand. So you just plug in some numbers, very, very close to negative 1, one number that's a little bit smaller, one number that's a little bit bigger, and you see if you're getting positive or negative numbers. All right, for our last example today, I want to do a question real similar to this one. I'm going to make one tiny change actually. So all I did, I copied the question down, and all I did was square the denominator, basically. It's still the limit as x approaches negative 1. Instead of x over x plus 1, I did x over x plus 1 squared. Now let's start the same way. Let's do our direct substitution again. So I plug in negative 1 for x, negative 1 plus 1 squared. So I get negative 1 over 0 squared, and 0 squared is still 0. So I definitely have a vertical asymptote. Again, that part didn't change. So what I want to do now is go back to Desmos. I'm only going to do Desmos this time. I'm not going to plug in numbers. But let's go back to Desmos and take a look and see what it looks like. All right, so you guys can see I just made one tiny little change here. I added some parentheses in the denominator and put that squared in there, the exponent of 2. So now instead of x over x plus 1, I have x over x plus 1 squared. Now I'm still doing the limit as x approaches negative 1, so I'll leave the blue line right there. You can see it's still a vertical asymptote, but what changed is that instead of having it turn up on one side and down on the other, it's turning down on both sides. So actually the limit from the left and the limit from the right both equal negative infinity, and that makes that our answer for this question. So the answer to this question is, it's not D and E, it's negative infinity.